Kia ora, good evening. Welcome to one more session of Code Night New Zealand. And tonight we have Justin. Yo, how are you?
Hello, hello everyone.
Well, it's such a pleasure to have you like in our user group. Just being waiting for anxiously just to have you come and share some great content with us. And tonight you're bringing like very interesting topic, right?
Okay.
Implementing resilient Azure OpenAI for your service.
Mhm.
What exactly you're gonna cover?
Yeah, that's really good questions. Actually, the title says itself. Actually, so we are implementing the Azure OpenAI service for your like the customer-facing services. If there is a case, you might be facing a certain issues. So how can we overcome that kind of issue through a different the perspective?
Well, interesting. Yeah. As a developer, for sure, I'm very interested, like to get to know a little bit more about it. Justin, before you jump in, let me just introduce the user group to you. If you're coming here like for the first time, or if you're part of the user group already. But you know that we are a community of developers and we love coding and we follow best practices on software development languages and technologies. In general, we're more focused on the Microsoft stack, but we are open to all technologies, really. And another thing is that the intent of the user group is that to enable developers with practical knowledge to excel and launch their careers, right? So if you're a junior dev, you're transitioning careers, or if you're a lead dev, you're always going to find great content in our sessions. I would like to mention that we're part of AzureTar.com. We are a cloud native group of, uh, I would say, passionate techs where we get to talk about the latest and greatest about the cloud native space. And also we're sponsored by the .NET Foundation, which is an open source. Well, it's an entity that looks after the open source .NET projects. With no further ado, Justin, the floor is yours. Let me just bring your screen.
Okay. Right.
Here you go.
So let's get started. Right. So hello everyone. It's really nice to meet you. Yeah. So and thanks for joining our session today because it's I know it's a Easter holiday, and where I live in for now is we don't celebrate the Easter holiday. So I so yeah really appreciate your the participation tonight. So yeah, the topic for tonight is how to implement the resilient the Azure OpenAI service onto your service. So especially from the perspective of load balancing. So there are a few tips and tricks of how to implement load balancing with different the perspective. So let's get into this. So yeah, so let me introduce myself. So I'm Justin from Microsoft as a principal cloud advocate. So these are my LinkedIn and GitHub profile. So if you follow me on those things, and you will be able to see a lot of code samples on my GitHub profile, mostly on Azure and .NET. So yeah, so that's it.
Nice.
Right. So let's begin with the demo first. Yeah. So we are like demo first this session.
Nice. I love it. Yeah.
So I'm going to show you a simple, very simple web application that generates a playlist for me from the Spotify based on my feeling captured by Azure OpenAI service. So this is the sample the architecture. Like there is the web application, and there is backend API application. That API talk to Azure OpenAI by sending my feeling to the Azure OpenAI, and then Azure OpenAI service the analyzes my feeling with a few like the 5 different the words, and then based on that keyword, that the keyword will be sent to the Spotify, and Spotify will generate a playlist for me. And for the authentication and authorization purpose, I use the API management for the Spotify. So this is the current the application architecture. Looks very simple, right? So let me try. Where is my Visual Studio? Okay. So this is my Visual Studio. So I'm going to run this application. Then I will. So it's running soon. Oh, it's running in different place. So this is the application. Can you see it? Okay.
Yeah,
So
nice.
this is
Yeah.
the application. Now I'm going to put these lyrics. So you might be aware of these lyrics. Isn't she lovely? Isn't she wonderful? Yeah, that's Stevie Wonder. So I'm going to push this button, get playlist button. Then it returns with. Let me check. Does it work? Does it work? Really? It doesn't work. It doesn't seem to be working. Oh my God, what happened? It was working before.
Okay.
Oh my God. Oh, application seems to be down. Interesting. Here we go.
There's a breakpoint.
Oh my God. I need to disable this breakpoint. Okay. Yeah. So, so it will be okay like this.
Nice.
So based on this, the sentences, and it returns the Azure OpenAI, the analysis, the feeling or the sentiment of that the paragraph, and based on that, the keyword, it will generate the Spotify playlist and returns it, something like this. Okay, so that's pretty simple, right? Now, so I'm going to stop it. And back to the slide. Okay, so as I mentioned, this is a very simple application. But let's think about which factors should we consider building this application architecture, because I think web application itself is fine, and API application itself is also fine, but there might be an issue on this part, the Azure OpenAI service, right? So let's try to analyze. But before doing that, let's discuss the well-architected framework. So what it does is that Microsoft offers well-architected framework, which stands for which is sometimes we call it a WAF. So what is this? So WAF is like a collection of best practices that we should consider when we build a new system on the cloud, or when we migrate the existing system from on-premises to the cloud. In terms of the technology wide, there are not many limitations that we apply to the system, because technology is possible. Everything you can do is possible, actually, literally possible. But it might be a different story when we start thinking about security, robustness, cost effectiveness, and so forth, right? Therefore, we should consider those perspectives when we build or migrate our system to the cloud. In other words, well-architected framework is a collection of views to consider when we design an architecture. So I said views or perspectives. So what are those views? Well-architected framework, WAF, proposes these 5 different perspectives. So first one is cost optimization, operational excellence, performance efficiency, reliability, and security. Therefore, when we build a system architecture using WAF, you will be able to get the successful implementation, then get the trust increase because of this successful implementation. Then you will be able to understand trade-off and risks. And finally, you will be able to optimize the system over time after time, because it's not just one of things, it's continuous effort. So let's take a look at the first one, cost optimization. Let's say there is a technology we are interested in, and this is so good. but it's too expensive. From my organization's perspective, I wouldn't buy it because it doesn't show us enough return on investment values. We should consider whether we've got enough budget, how we pay for it, or maximize return on investment the values on the resource by increasing the usage or reducing cost or something like that. So everything we do is need money, right? From the company perspective. So sometimes if we optimize the cost too hard or too harsh, then it will also impact on the other four pillars and overall the performance or something like that. The next pillar would be the operational excellence. In this pillar, we generally talk about DevOps related ones, as well as configuring standardized development environment or something like that. The operational situation should be under the control, right? Rather than leaving that unexpected. Sometimes back in my the early developer days, sometimes we do like right-click publish for the production. And while doing those right-click publish that stuff, literally anything can happen. And once something happens, we have to roll back. And while application being rolled back, another issue is happening or something like that. Everything was unexpected, which was not desirable. So we have to be able to anticipate what's happening in the next time or something like that, right? So that's the operational excellence. So how can we do this? Like implementing monitoring systems or monitoring features. That can be one of the efforts, or maybe something else we can do. What about the performance efficiency? We should be able to deal with the increasing workload without giving up the user experiences, right? Well, what that means is that like end users, like customers, can use our applications without being disrupted, right? Without being impacted on their user experience. So as like nothing's happened, but actually something happens behind, right? So in this case, scaling is one of the factors, right? In this category, for example. Let's talk about the reliability. Your system should be running without experiencing downtimes. There might be an issue on a specific part of our system, but it should be recovered from the fault by auto-healing features or something like that, so that our overall system should always be running consistently. And of course, the end users doesn't have to know what's happening behind. But the reliability, it requires more cost operational effort. It requires more cost or operational effort. So we should always consider its trade-off. The more we pay, the more we pay for the reliability, the more the cost is going up, right? And the more operational complexity is going up. So we need to compromise in between at some stage. The same goes into the security as well. So any data moving from one place to another should be encrypted. And encryption requires cost. And encryption requires additional operational effort, something like this. We should, and as well as in addition to do that, we should always assume that there must be a security vulnerability we are not aware of. Therefore, we should provide multiple security layers to protect our system. Another thing we should consider is that, security hole in one place doesn't get propagated to the whole system. by isolating them very well. But you know, as I said, the more secure the system is, the more money we need, right? So there is something in between. We need to agree with everybody. So if you like to explore more about the WAF, this is a QR code or link, the aka.ms/WAF. So take this QR code and you will be able to see this document. And I just briefly mentioned about the 5 different pillars, but there will be comprehensive materials you can check out. So visit this URL and read it through and thinking about how you can apply these best practices into your application architecture. Now, there will be questions like, oh, is well-architected framework, is WAF also applicable to the Azure OpenAI service? So the short answer is yes. Short answer is yes. And actually, the WAF talks about individual Azure resources as well. So, and Azure OpenAI is one of them. So this is the page in the WAF page. So take into this QR code or going to visit the URL aka.ms/waf/AOAI. Then you will be able to see this, how we can apply as a well-architected framework into the Azure OpenAI service. And it covers comprehensive things. But there are a few points to pick up for tonight's session. So for the cost optimization stuff, you know, when we think about when we use Azure OpenAI service, we send the request, right? And that means the Azure OpenAI is charged by token, right? How many tokens we used? That's the base of charge, right? And if we send the request too many times within a given period of time, it will be throttled, something like that. So these things impact on our cost optimization factor, right? The more you send the tokens, the more we pay for the request. And also, the newer the OpenAI model we use, the more expensive we should pay. So of course, we all know the newer model is more accurate, more accurate and better. But it depends on your business requirement. Sometimes your business requirement only needs GPT 3.5. Sometimes your new business model might require GPT-4 with vision, right? So there are different the rate applicable. So we need to think about this. Another one is operational excellence. From the operational excellence perspective, we should consider like infrastructure as code, like Bicep, for the resource provisioning, so that we don't have to do it manually. So let's take a quick demo how we can provision Azure OpenAI service, Azure OpenAI instances, and other resources all together with Bicep. So I will show you. Okay, so this is this is Bicep file. So within this Bicep, so it has okay, I'm going to provision API management. I'm going to provision the app service. So everything is automated. And after that, it says, okay, so where is my, so this is the Bicep, the AZD one. So once we provision all the resources, and it will deploy application to these two applications, two app service instances. And finally, after that, we run another the post provision script like this. And within there, we provision something like Azure OpenAI instances like this. Right? So how can we do this? So there is some environment like that. So AZD en list, and it says, okay, I have two environments set up for now. So for now, so we use playlist 0401, which is today. And so AZD, what I do is just simply AZD up or AZD provision. And by doing so, it will deploy everything we need. Right? It will provision all the resources we need. Think about this. It is for like our development environment. And what happens, we will need to provision another environment like test or staging or production. Then what should we do? Should we do all the things through Azure portal or using the Azure CLI, which is the imperative way? But using the bicep, we can declare all the resources what we need. Then, yeah, just simply use AZD provision or AZD up. Then, yeah, it automatically provisions everything within a minute or within, within a second even. Yeah. So this is one of the example of operational excellence. Now, let's get back to the slide. Another one is performance efficiency. So I mentioned earlier that Azure OpenAI service has a throttling. So if we have only one instance of Azure OpenAI, then it's likely for you to get throttled at some stage. Like I think within a minute, it only accepts a few the times of call. And within then, what if there are multiple requests comes in within a very short period of time? The API will be throttled. We need to get through that. So how can we do these kind of things? That's something like we can provision multiple Azure OpenAI instances in different regions. So that's something called the redundancy, right? So yeah, so something like we need to consider these kind of things. And each the Azure OpenAI service instance has its own the API key. Then how can we store those API keys in a secure places, like in Key Vault or API management named values instance, something like that. So we need to find a way where to securely store our API keys in order not to being compromised from malicious attacks, right? So yeah, let's get back to the first demo. So, but this time I'm going to show you how we can use API management from that side, right? Instead of going into the web application itself. So where is my API management here? Okay, so this is my API management stuff. And there is the check completion, the API, and I'm going to use this one. So I'm going to use the model. I use model GPT-4 32Ks, and I'm using this API version or the latest API version. And instead of using this payload, I'm going to just simply use, replace this. So basically it's the same. So I'm just using the lyrics from the Stevie Wonder's song. And yeah, so simple thing. So I'm going to send a request to that. Then it will return a result. It should be returning a result without any issues. Just it takes time because it's the first time in a while. Okay, so I get the result, right? So I get all the result, and I will send this again. Then, oh, it happens on 429, which is throttling error, right? Because I use the same endpoint every time. Now, we need to get through this issue, because if you are facing this error for your customer bases, customers will send a request a lot of times within a very short period of time. Then the first or second request would be fine, but the following subsequent request will be able to see these errors. So we need to avoid this kind of situation. So what should we do? In other words, as I said, so this really happens in the real world situation. In that case, we should implement a load balancing feature to distribute all the traffics. So which is the main topic of today. I will show you the 3 different ways to implement load balancing. So this is the first approach that we are going to use the code base So which means inside the app, we are implementing load balancing feature. So how can we do this? So all the connection details for all Azure OpenAI instances will be stored in one place using like an app settings.json file. And then within the code, it will pick up randomly one instance every time the request comes in. Right? So let's get back to the another demo. This demo show you in-app development load balancing feature, and the architecture has slightly changed. So basically everything is the same except that part, Azure OpenAI service. So before that, we have only one Azure OpenAI instance, but this time we have 6 different Azure OpenAI instances as like a pool, right? And that's 6 different instances because there are only 6 different regions that we can provision Azure OpenAI the GPT-4 32K deployment model. So I use all the 6 different regions for this. So let me show you how we can code this. So let's get back to the slide again. Now I'm going to enable this the breakpoint here. Now, because okay, so there are 6 different the ones, right? There are 6 different the API endpoint like this. So when I run this application, it will open Swaggle, not this one. Okay, here we go. And this time I will send another request, like different lyrics. Okay, so can you guess what this lyric is from? That's Michael Jackson's "The Heal the World" song. So yeah. I will create. I will click this button, get playlist, then see how it's going. And then it hits like this. So as I said, I have 6 different Azure OpenAI instance here. So it will pick up a random number like this. So this index is number 2, which is coming from the East US, right? And then it will return the mood analysis and generate the playlist like this, right? So now I will change it and clear. Oops, I will change this. Now I will send this time again. And this time it used to be number 2. Now it used to be number 5. Okay. So what's the endpoint for that? Okay, Switzerland North. So it automatically pick up different regions by randomizing the numbers, right? So by doing so, we always pick up a different Azure OpenAI endpoint to send the request. So from the code perspective, we always send a new or we always send the request to the Azure OpenAI service, but the application itself doesn't know which instances will be hitting, right? Because it randomly picked up.
Yeah.
Now let's get back to the slider. So this is how we manage this one. It actually works, right? But also it brings another issue, like all the connection details, connection strings are managed within the application, like development, dev, test, product, staging, or so. Let's think about this. If your application is deployed like a multi-targeting global the regions, right? Multi-region style, and then the production itself will have multiple the Azure OpenAI services instances as well. Like, so if I say dev, test, production, enough, it's already 18 different Azure OpenAI instances have. And if we targeting different the regions, then it is multiplied, right? So how can you manage these kind of connection strings within the application? So it's kind of conversion, and I don't think it's a good idea to manage those connection strings within the application. Instead, because we have to this because it's a dependency on our Azure OpenAI connection details. So in this case, we need to separate them. We need to decouple the application from the connection strings. So how can we do this? Instead of storing those connections, 6 different the instances connection details within the application, we move these connection details into the load balancer side. And application only knows one endpoint, which is load balancer endpoint. Right? So by doing so, we can simplify this application side, and as well as we decouple our application from the connection strings, right? And load balancer will take care of those connection strings. Now, so what types of load balancing service does Azure offer? There are roughly five different load balancing services, like application gateway, Azure front door, Azure load balancer, and Azure traffic manager, and network virtual appliance. But the Azure traffic manager and the network virtual appliance has a different focus. So we are not going to talk about that. But depending on your business requirement, application gateway or Azure front door or Azure load balancer will be used. And the real difference is they are very similar to each other, but the real difference is that both application gateway and Azure front door uses layer 7 HTTP protocol. On the other hand, Azure load balancer uses layer 4 protocol like TCP or UDP or something like that. And application gateway supports only single region. On the other hand, Azure front door supports global region like this. And Azure load balancer can support internal facing load balancing feature, something like this. But application gateway and Azure front door doesn't support internal facing load balancing feature. So depending on your business needs, you need to provision these load balancing service for your the application. But again, it requires additional resources, right? Which means we need to pay more. So which is slightly concerning from the cost optimization perspective. So how can we save this amount? Like, what if we can use existing resources? So this time, I'm going to show you how we can use load balancing feature within the Azure API management. Right? So Azure API management, we can save or we can store all the Azure OpenAI instance connection details into Azure API management backend service. And we can control these backend with API management policies. Right? And there are two different ways of using the policies. And the first one is round robin feature, manual way. Right? So we need to handle this round robin feature by ourselves. So I'm going to use this manual round robin feature first. And if we put all the Azure OpenAI service connection details into the Azure API management, it will pick up random Azure OpenAI backend the connection details. It's like, so we have the same thing already happened within the application side, right? Now, we are going to use every connection, random picking up things from application to API management. And how can we do this? Is using the API management policies, right? So let's get back into the application. So manual load balancing feature I'm going to implement through API management. And the architecture has changed like this. So before that, we only use the API management only for Spotify authentication stuff. Now we are going to use existing API management for load balancing as OpenAI feature, right? So let's get back to here. So I'm going to stop this, and then this time I'm using I'm enabling this. Now, oh, so let me show you. Okay, so I'm going to show you here. So I have stored, so there is called the menu, there is called menu backend, and I have stored all the 6 different Azure OpenAI service instances here. So it has all the connection details for me. Now, with these connection details, I'm going to deploy, I'm going to update this the feature or that part. Okay, so we only use one API endpoint, right? And now what I can do here is that there is a policy that, but okay, here we go. So I'm going to copy all the things into here and change it like this. So what I can say is that here. So what it does is that I stored all the connection as OpenAI connection details in like 6 different OpenAI instance. And when a request, incoming request comes in, hits this endpoint, it picks, it gets the one random number from 0 to 5. Then based on that number, it will take, 0, 1, 2, 3, 4, and 5, right? Which represents a different region. So if I do this, then the same thing will happen, right? And here, okay, so like this. Now let's take a test here. And I will send the same request again to that part. So using the same model, same the deployment model, and using the same API version, and I'm going to use the same request payload. Now this, then, so let's hit the trace button. Then it will send, it will return the result and say the traces. And if I go down, scroll down here, then it says, okay, I'm hitting, where is it? I'm hitting the Australia East. Right? If I send another request, then it hits, where is it? East US. And if I send this request again, it hits, another East US. And if I send it again, then this time it hits Switzerland North, something like this, right? So every time the request comes in, Azure OpenAI, no, the API management policies randomly pick up the different Azure OpenAI instance and send a request to that service, right? And what happens on the application side then? So if I run this application, here we go. So the same lyrics. Okay, same lyrics. And if I choose, if I choose to use API management here, then if I click this button and goes into there, and it goes into the endpoint of API management side. So now, from now on, the application only knows API management, and API management takes care of the rest, right? And it will return the result like this. Okay. The core thing is that we are running this one uses these policies, right? And this looks a little bit overwhelming, because I have to, if there is not enough the knowledge of how we can use policies, then it will be very hard to maintain. And if there are more than, if there will be more than more Azure OpenAI instances, and the list will be getting longer, right? Getting longer and longer. And once, so how can it's kind of the risk on the management from the management perspective. So how can we can we reduce the maintenance effort on the API management policies? I think so. That's the next topic. So how can we do automatic load balancing, right? Because there is a risk, possibility to get those policies messed up. So if Azure API management support the load balancing feature by itself, then why not? Why not using that? So API management has a backend pull feature, which is recently released as a preview feature. So you can use that, right, for the automatic load balancing feature. So I'm going to use the same thing, but this time I use the internal load balancing feature, which is preview feature of API management side. Okay. So what I can do here now is that instead of using this policy, I'm going to use the new one, which is not this one, this one. So instead of doing that, I just change this one. So there is only one line here, and it calls load balancer, right? Oh, that's interesting. So I save it, and where is the load balancer? So I go into the backend again. There is a load balancer here. And this load balancer has all the information of these 6 different backend. So which is because it's working as a load backend pool. Okay. So and unfortunately for now, because it's a preview feature, this load balancer should be provisioned through Bicep, not Azure CLI, not Azure Portal, only through Bicep for now. But when it becomes generally available, who knows? It might be able to use create this load balancer feature on through the Azure Portal or Azure CLI. But for now, you use the Bicep for this. Okay. So anyway, so this load balancer takes care of the round robin feature internally. So we don't have to worry about manually picking up randomly or something like that, right? So go back to the API here and go back to this API again. Now I'm going to test the thing instead. Okay, so I will send another request to deployment ID, API version, and payload. Okay, so replace it. Now I'm going to send the request to the API management backend. Then it will say, let's say trace. Go back, scroll down, then scroll down. Here we go. It says it sent to the backend pool. And it goes into the East US. If I send that again, then backend pool, it goes into Switzerland nodes, right? So it automatically the round robins for me. And this time France Central, right? So every time I hit send a request to my API management, and the internally API management round robins all the Azure OpenAI the service endpoint, so that the application, front-end application itself, doesn't have to worry about those kind of things like a request throttling or whatsoever. Okay. Now, so yeah, so we're done. We're done. So that's all I have. So let's conclude this the talk. We have dealt with the load balancing feature for the real-world implementation for Azure OpenAI. First, we briefly discussed what well-architected framework is. It's only a little bit that I mentioned here, but if you need more about Azure well-architected framework, please visit the website that I showed you before. Then, how we can avoid those request throttling on Azure OpenAI service, because it typically faces our day-to-day implementation. So I suggested 3 different load balancing approaches. And the first one is in-application load balancing feature, using our C# code, right?
Mhm.
And then we use the huge amount of the Azure API management policies for like a manual load balancing, right? By picking up and random the API management, the Azure OpenAI instances. And finally, we use the new preview feature for API management, automatic load balancing feature. Okay, so these three approaches, I don't say one is better than the other two, right? Nothing, no one thing is better than the other two. So all you need to consider is your business requirement, and this is totally up to your business. You know, all we need to consider is to remember these the well-architected frameworks, 5 pillars, right? And which is these 5 pillars are cost optimization, operational excellence, performance efficiency, reliability, and security. Right? Remember these 5 pillars. Now, it's time to try. It's time for you to try. Right? I use this sample application from this GitHub code. So take this the screenshot here. So github.com/devkimchi/mood driven playlist. So this is the application I used for this demo. And there are a bunch of API management resources document. So API management, and there are a bunch of other policies as well, and the new feature of backend. So please take a look and take a consideration into building your application. Right? So thanks for listening. If there is any question, I'm more than happy to answer.
Yeah, thanks, Justin. Yeah, that was well really cool. I've been doing a
Mhm.
lot of APN policies and
Right.
knowing about like, this feature with the load balance, right? Like being
Mhm.
in preview.
Mm.
Uh, is there like any particular instance, any particular tier that's disenabled or it's enabled in all tiers?
My API management is currently consumption tier. So load
Yeah.
balancing feature can be used from any levels, I think, for now.
Mm-hmm.
Mm. But because it's a preview feature,
Yeah.
but so we need to wait the exact pricing kind
Yeah.
of things until we have no idea until it's generally available.
Yeah, that's
Mm.
really really interesting like use case, right?
Mm,
For
mm.
what you bring with OpenAI makes completely sense to you leverage
Yeah,
that feature.
yeah. Mm.
Yeah. Well, that I learned with that. So I'm definitely checking the codes and exploring
Hmm.
myself.
Hmm. Hmm.
I'm a big fan like of fragments on
Right.
APIN,
Yeah.
and but yeah,
Mm,
looking at that like one single line to do
mm.
that work for us with the
That's right.
backends
Yeah, yeah.
configure. That's cool. Like
Yeah,
it.
it,
Love it.
it
Love it.
really
Yeah,
reduces our the operational effort, very the minimal line. So
it
which is really
is.
cool
Yeah,
feature. Yeah.
really good. I'm not sure like the audience has like any questions, but like that was like for me like
Hmm.
I learned a lot, right? So
Hmm.
that's very interesting.
Right.
Uh, let's just like came up like a question here, like from Jaiming. So hi Justin, yeah, for the OpenAI,
Yeah.
which pricing plan did you use? Can, can we have like a S0 or a free plan?
That's a really good question. I don't think Azure OpenAI service has a free feature, a free plan. I don't think so.
No,
So
yeah,
you need to pay for it, and then you need to have your Azure subscription, which is bounded your corporate, your company or organization. Otherwise, you cannot use like the personal use Azure OpenAI for personal use at this stage. But who know?
yeah,
But the I use the Azure OpenAI SDK. That SDK actually is compatible to both Azure OpenAI and the ChatGPT side. OpenAI is
mhm,
the API endpoint as well. So for that case, you might be able to use a free one, like a 3.5. But if you want to use like a GPT-4 feature on the OpenAI side, then yeah, you need to subscribe as well.
yep.
Mm.
All right. I think like that was the question that we had it.
Mhm.
Well, thank you very much, Justin. Yeah, that was awesome. Really loved like the demos. Every time, like, well, I've been following you like for some time, and every single
Okay.
time you present something, you come like a lot of good demos, right? So
Okay.
I was definitely expecting that, and yeah, that was exactly that.
Sure.
No, thank you. One thing like I would like to mention to the
Mhm.
audience is that, well, we're talking here like about Azure, right?
Mhm.
And we're gonna have the Global Azure Auckland happening like this month.
Wow.
So yeah,
Yay.
so on April 20th, well, we're gonna have like in-person session at Microsoft Auckland on the
Mhm.
April 18th,
Mhm.
and on April 20th, which is the Saturday, we're gonna have online sessions.
Mhm.
The details are available here. Have a look. The agenda for Thursday is already available, so you
Mhm.
should be able to see on globalazure.net. And also the meetup should be coming soon. And the agenda for April 20th on Saturday is also coming. So
Mhm.
just keep an eye on that for the audience, just checking the session. And yeah, we're going to have like more coming up on Azure Space. And yeah, just keep an eye on it.
Yep. So I'm really sure that the global AI, no, global Azure,
Yep,
sorry. So global Azure bootcamp is happening around the globe, and I'm pretty
correct.
sure that the New Zealand one is one of the best the community events as well. So I definitely encourage you to join, or even is the CFP closed already?
The call for speakers is still
Mm.
open.
Oh yeah, yeah.
We're
So why
we're
not? Yeah,
always we always have like those last submissions, right?
sure.
So
Yeah.
by
So
going
if
like to that link, you're
mhm.
still like in, oh wow, you still have the chance like to
Okay,
submit
right,
like sessions, right? So it's not like
sure.
fully closed. We're still
Yeah,
having slots available.
right,
So
right.
yeah, that's a good like call,
Yeah.
Justin. Yeah.
I
So
really encourage everyone to put your name onto the as a speaker because it's really a good chance for you to become a speaker. And speaking is not, yeah, it's not the scary things. So just share your thoughts into the event, and you will be a rock star, right?
yeah, good tip,
Mm-hmm.
Justin. Yeah, and well, I hope like you guys enjoy like the session today.
Mm-hmm.
Thanks again, Justin. I really appreciate like your time and your commitment to the community. And yeah, to the audience, well, we'll catch up like you guys on the Global Azure that's coming soon.
Thanks,
Th-
everyone.
Thank you. Cheers.
Bye bye.